Welcome and hello. This is a video exercise in HEC ResSim. And in this exercise, I'm going to be exploring downstream control rules. This is going to be a simple one reservoir network exercise, and we're going to start from scratch. So I got ResSim open here, and I am in the Watershed setup module. So once you're there, go ahead and file new Watershed. Go ahead and give that watershed a name. Location is the directory you want the watershed directory to be created in, and we'll just select the time zone and get things started here. All right, let me resize my window a little bit. Stream alignment tool. I'm going to just sketch out a generic alignment that I've used before. And then stream one. Okay, I'm going to add a computation point at the top of the stream. CP1. When adding elements, you hold down control. So like I'll select the reservoir tool, hold down control in the upstream end first, single left click, let go control, single left click. Reservoir one. Okay. And then the computation point, hold down control, and I'll call it CP4. Okay, this is the generic network I've been setting up and using a number of times, and that's because it works. Let's see. Let's go ahead and add a configuration. Configuration new. I'm going to say config 1 hour time step is fine. Okay. And let's save that watershed and move on to our reservoir network module. What I want to do is create a network and bring in that configuration that I just created. So we'll get our junctions and the reservoir popping up into place here. Network one, it's going to be based on that configuration. I'm not going to spend time writing out descriptions for an exercise like this, but that's probably not a bad idea. And then I'll click the reach tool, hold down control on the upstream junction, let go of control, single left click on the next downstream junction. CP1 to CP2 is the default name. I'll just prepend the word reach to it. So that's the name of that reach. And then do the same thing down here. CP3 to CP4. Okay. So I got one reservoir, I got 4 junctions, and I got 2 reaches. We can take a look at those data points here in the reports. Check out the junctions. That's great. If we want to know the junction stationing, that can be looked up over in the watershed setup module. Actually, let me save my network real quick. Then we reports and computation points, excuse me. And then we have the stationing here on this penultimate column of the table, which is sometimes helpful. All right, back over to the reservoir network. Let's go ahead and start defining the reservoir by click on the reservoir tool, right click, edit properties. And one thing I always like to do is to rename the dam just to dam. There's only one dam. I could call it dam one, but it doesn't have to mention the stream per se. So that name gets updated here. And then I'm going to say, let's define the reservoir geometry here by clicking Pool. And over in my Excel file off screen, I have the dimensions that I've been using. So feel free to pause the video and use my numbers if you want, or just make up some of your own. If I double click over here, I get the plot for storage versus elevation and area versus elevation. All right, that's fine. The top of the reservoir is 1,500 feet, so I'm going to just use that same number here. And then for dam length, oh, it doesn't matter, 1,200, sure. Okay, I'm going to add a controlled outlet now, and that's going to ask me for its max capacity based on those elevations. Okay, I'm going to paste in some numbers. The invert is 1,400, so there's actually 50 feet of elevation below that lowest invert. I suppose that could be considered the inactive zone, but whatever. Let's say there's 3 gates, so that would multiply this far column by 3. So we have 200 here, and then we have, I'm sorry, 3. There we go. 200 here and 600 here, 380, 1140, and so on. Click apply and then use all the default settings here, like max capacity only. So that was the physical tab. And then the operations tab, I'm going to go ahead and start by creating an operations set 1. Okay, gives me the three default zones. I can obviously add zones, remove zones, and define them as I wish. I'll say the flood control zone is at 1500. The conservation zone is a constant 1420. Apply, and then inactive will be 1350. It could be 1400, but we'll just go with that for now. All right, so the plot is shows up here, shows those three top of zone elevations, and the conservation zone is the guide curve because it's bold, and on the plot it's blue when it's not selected. All right, so let's go ahead and add a rule. Right click and add rule. It's going to be a rule called downstream control at CP4. That's the downstream most junction. We have to select reservoir here because the downstream control function rule is only available for reservoir. See, if I click dam, we don't have that option. I click controlled outlet, not there. And then we need to define the location. That's going to be the junction CP4. What we want to do is say there's a minimum required flow at that downstream junction CP4. So I select minimum here and I select flow from the parameter. Then I need to define how the release is a function of the date. We have other options there, but I'm going to keep it simple. Select date. Now I need to paste in some date data. Okay, so I'm Control V to paste from my clipboard. I just have some Excel file data saved, and here it is. So the downstream minimum release is between 800 and it dips down to 750 and then back up to 800. So I'm going to click apply. And then I'm going to right click on the rule over in the zone rule tree and then just say add to all zones. So that's now part of the conservation zone and the flood control zone. Click apply, OK, and then I always get in the habit of going to network and save. Next, let's create an alternative and we'll do alternative new. I'm just going to call it alt one. Um, I started, yeah, so there's a 10 character limit on the name of the alternative for some reason, and I haven't ran into that problem naming other things. So that's the reason why I'm going with alt one. 1 hour will be the time step. We can just leave that standard. Operation set is the set we just defined. Okay, for look back, let's just start it at the initial values of 1420, which is the guide curve elevation for our guide curve zone, which is the conservation zone. And then the flow rate initially will be 1000 CFS, which is what we're going to define next. So time series, I need to go ahead and identify that CP1 is my inflow. So let me save the alternative, close that. I go hit, click junction, right click edit, and then this local flow tab here. I'm going to go ahead and type in inflow at CP1. Factor is going to be 1. Apply. Okay. So back over at the alternative, I have my inflow record here. And then I'm going to select the DSS path, which is a time series data set to represent the inflow over the time period. I want this time period to be 1 year. I'm going to use the year 2022 for this simulation or this alternative. So let's go ahead and create that data in DSS view. So let me, one sec, save. Okay, it's been saved already. And go over to Tools, HEC DSS View. You can open up HEC DSS View independently as a separate application. I need to create a new .dss file. This is my Watershed directory. So let me just put it in here. That looks fine. I'll call it time series data.dss create. Okay, the file's been created. Go ahead and manually enter just a constant 1000 CFS for the year 2022. So project, location, flow, 1 hour is fine. I mean, 1 day would probably work fine as well. And I'm just going to give it a label 1000 CFS. Now, if you actually were working on a project, you wouldn't just say project, you'd say American River at Folsom Lake and so on. Start date's going to be January 1. So it's going to be the full year. The first hour of the year is when the time series is going to start. Units are CFS. And then I'm going to select not the manual entry tab, but the automatic generate tab and type in 1000 for the flow and CFS. And then the end date is going to be December of that year. It's going to be the last hour of the year. Okay, hit generate. And here are the numbers. We can look at it on a plot. There it is. Just as expected, 1000. And then save. Don't need to edit anymore. It came in as individual months. So this is the month of January. If I highlight them all, I see all the months. But once I bring that in to assign it to the time series for my CP1 junction, it'll be just one single record. So let's do that now. Go back to alternative, edit. Now select this select DSS path button down in the bottom right. Now let's navigate to that .dss file we just created. Open. Here it is. Okay. And then here's the time series for the entire year. So we're going to go ahead and click this set path name button. And when we do, this record will be populated behind the window. Okay. So there's that. All right. We're ready to go. Create a simulation now. So let's save the network one more time before we navigate over to the simulation module. Now, don't worry that there's nothing displaying right away. We need to create a simulation and assign that alternative before we see the map. So I'm going to go simulation new. And for lack of a better name, I'm just going to call it simulation one. The start date is going to be the same as the year. It's going to be the full year of 2022 again. So we'll go Jan 2022. I'm actually going to start on the second hour of the year because the look back period will be the first hour of the year. So I'll just copy this to save a little bit of typing. And this will be the first hour of the year. And then this needs to be December 31st, the last hour. And then we'll click that. Okay. Looks good. And we're ready to run. So I'll click the compute button. It ran. It looks to be successful, at least no noticeable problems. And let's go ahead and peek at some of the plots. So what we see here in this plot is our constant flow of 1000 CFS for the entire year of 2020. And then this dashed line that has a fill below it is the downstream control. So this is like the demand for this CP4 junction. So obviously we have plenty of demand met all year long. Let's go ahead and peek at the reservoir by right click and plot. And this is not too exciting. It's kind of what I expected to see. So I'm going to hide the legend real quick. And we have the top of the flood control zone and then the top of the conservation zone, which serves as our guide curve. And this green line represents the water surface elevation, which holds constant at 1420 for the entire year. And then at the bottom, we just see the release is 1000 CFS release through the controlled outlet for the entire year because that's what our inflow was. So if we check the flow rate at any of the reaches, we'd see that constant 1000 CFS as well. So just to be complete, there's that. Okay, so that's exciting. That's a good place to start. Now, what I want to do in an alternative two is to change the downstream control. So I'm going to go back over to just change the numbers a little bit. Right click on the reservoir, edit reservoir properties. And I need to create a new operation set. So I'm going to actually rename this rule because it's not, I need to make it distinct from a second operation set rule. So let me go ahead and hit rename operation set one. Okay, that looks good. And then apply. So I'm not changing any numbers here for our operation set one. I'm going to go operation set two now. Two. And I just remembered that I can duplicate. So let me go ahead and delete that operation set, number one. And then it's going to give me, so it gave me number one. I'm going to duplicate that one just to save a little bit of work. Operation set two, click OK. And then I basically have a copy. What I'm going to do is remove this rule. Oh, I should have removed it from all zones. Okay. Now I'm going to create a different downstream control rule for operation set 2. It's going to be similar, but not exactly the same. So a new rule, and I'm going to call it at CP4 operation set 2. Okay, so that's going to be a reservoir rule, downstream control, and then we'll specify CP4. Okay, I'm going to, let's go ahead and make it a minimum flow again, and based on the date. Now I'm going to paste in some different numbers, and these are going to be some higher flow rates. Paste. I'm going to actually change it to step as well. If we double click, we can see the plot here. And remember, we have a flow rate of 1000 CFS coming into the reservoir. It won't be a problem satisfying the downstream demand for the first 1, 2, 3 months. But then at the beginning of April, the that downstream control is jumps up to 1100, and then 1200, and then 1150, and then back down to 1000. So let's see what happens with that. I'm going to copy this rule to the conservation zone. Okay. And then click apply. I'll click OK, and then save the network. And then I want to create a new alternative. So we already have alternative 1. I'm going to say alternative new, and just alt 2. Okay. And basically, I'm going to specify all the same information on the Run Control tab and the time series and the look back, but the Operations tab is going to be what's different. I'm going to specify Operation Set 2. And then look back, I'll just type in the same numbers. Start with 1000 CFS flow. Oops, I'm sorry, this is 1420 as the starting pool elevation, which is right on the guide curve. And then the time series is going to be the same one. We can just use the same one. We don't have to recreate it every time. So that's nice. That's been set. Okay. And then let's save our alternative 2. Okay. Awesome. And then save the network. Let's head over to the simulation module and then add that alternative 2 to our simulation just by clicking on that checkbox, and then right click to set it as the active alternative. And let's go ahead and compute. Okay, that's cool. That looks good. And let's see what our results look like. We have our plot here, and this is interesting. Let me go ahead and zoom in a little bit on this section here. What happened was we have our demand. This is the downstream control flow at CP4, our downstream most junction here. And it is above the 1000 CFS line, which we knew was coming. But what's interesting to me is this curve here of the release, or it's really the flow at CP4, but it's the same thing as the release from the reservoir because there's no routing and there's no losses in the reach. And it jumps up to 1100 CFS at the very beginning of April because that is the downstream control flow. But then after a very short while, it resumes its 1000 CFS flow through CP4 and also through the release, of course. So if I right click to zoom out on the map, you can see, and then zoom in again, we actually have what you may call a shortage at that downstream junction, CP4, for 1000 CFS, 2000 CFS, and 1500 CFS for the months of April, May, and June, respectively. And then what happens here at the beginning of August, the downstream flow and is now 950. Let me go ahead and take a look at the reservoir data. That may answer a few questions. So I'm going to go right click plot, and then let me remove the legend. Okay, this is sort of what I expected to see. Let me zoom in on this section here. What I'm seeing is a drop in elevation and volume right when the beginning of April happens and this extra release takes place. So I could do a right click tabulate, and let me clean this up real quick. Okay, I resized a couple of the columns. So all we're seeing here is the date time, and then here is the elevation in the reservoir, which is the top green line. And then over here on the far right column is the release from the reservoir. Now, this is January, so we're starting over here with the constant 1420 elevation and then a constant release of 1000 CFS. But let me scroll over until the beginning of April. And then, okay, here is the beginning of April. And what we see here is this is the first hour of April and the flow increases to 1100. So it was 1000, now it's 1100. And as I scroll down, it stays 1100 until for the next 12 hours until noon. And then at 1 o'clock, it starts dropping down again. And then it looks like it just over the course of the next 5 or 6 days approaches that 1000 CFS. And that results in an elevation in the reservoir of 1417. So it comes down from 1420 to 1417. I mean, the table matches the plot. I don't fully understand what's going on. I'm not going to lie. But if I scroll over to the beginning of August, the demand drops to 950. The reservoir is basically only releasing 950 here as a way to fill back up to the guide curve elevation, which is 1420. So it was 1417. And then let me just scroll down to the beginning of August. Here's the beginning of August here. Yeah, so it drops down to 950 release. And when that happens, the elevation of the water surface in the reservoir pool begins to increase 1418, 1419, and then 1420. And then that's when the 1000 CFS release resumes from the reservoir. Okay, so I can understand what's happening here, but uh, I can't fully describe what's happening here. If it was so important to keep the reservoir pool elevation at 1420, then why release 1100 CFS and drop that elevation below 1420 at any time at all? And then on the flip side, if the downstream control was so important, then why are we not releasing 1100 CFS for the entire month of April and 1200 CFS for the entire month of May and so on? So I knew this was going to be an issue when I before making this video, and I debated even making the video at all, but I wanted to demonstrate a full example of downstream control rules and looking at plots and tables and data. And there's still a little bit of doubt in my mind as to what's going on here and why the reservoir decided to release what it did here in this situation. So that's all right. It's when I figure it out, I'll make another video, a part 2, and explain it then. But until then, I hope you all found this video helpful.